here. So I already gave students 2 minutes to complete the multiplication practice at the top of page 38. Students are reminded, homeworks 85, 6, and 7 were collected yesterday, dead next week, Wednesday. Homeworks 88 through 91 are being assigned this week. Those will be due for the first time next week, Tuesday. Students received CF 22 back earlier this week, and they have until Monday, June 2nd to retake that. There is an assessment of some kind every single week for the remainder of the year. We have a CFU this Friday, test next week, Thursday, quarterly assessment for fourth quarter the following week on Tuesday, and then the last day of the year is CFU 24. Again, if it's something that would hurt your grade or you're not here to take it, you'll by default be excused from it. It will only be entered if it would help your grade. Okay? Now, I said before that I wasn't going to spend a whole lot of time on the bottom of page 38. I'm just going to highlight a couple quick things. Okay? Every single function we look at today, every single function, and the ones you might see on tomorrow's CFU, they will have a vertical asymptote right here at x equals 0. Every single function we look at today, every single function on tomorrow's CFU will have a horizontal asymptote at y equals 0. Okay? Now, later on next week, we'll start to look at versions of these rational functions that get moved around, where they have, a horizontal asymptote at a different location, maybe, y equals -5 or y equals +3. They'll have a vertical asymptote at a different location, like x equals -8 or x equals +2. But for today and tomorrow, we're just limiting ourselves to functions at x equals 0, y equals 0. Okay? Now, with the first problem of the day, so if you haven't already, go ahead and turn to page 39. I wanted to give you all a chance to get this problem started. I want to see if you all can anticipate which numbers I am going to choose to fill in the table. So here's what I'd like everyone to do. Go to y equals and type in that function. So take out your calculator, go to y equals, and type 6 divided by x. Now, by the way, if you open up your calculator and you see something like this, that was the last problem that we did in the last class. So remember, as a general rule, it's a good idea to reset the calculator, just in case somebody else did something with it. So second plus 712. Okay, and then go to y equals. Everyone please type in 6 divided by x. Do that now in y equals. Now, what I want you all to do again is I want to see if you can figure out which values I decided to copy from the table. It says, complete the table and graph. Be sure to include some negative numbers in your table. So when you go to the table, do not just copy positive values, but back up and get a couple negative ones as well. Okay? Take a minute and see if you can figure out which values I chose to copy. Go. All right, so again, the directions were to select some negative values. Notice it's 6 divided by x. So my first instinct, honestly, the easiest number I can think of to divide 6 by is 6. So what I actually did was I jumped all the way up to -6 and copied that point. That was the very first point I chose to copy, -6, -1. I then skipped -5 and -4. Now, I did see 2 different people copy -4. I don't have a problem with that because honestly, graphing -1.5 isn't that bad, but I wanted to stick to whole number values. If I can stick to whole number values, that's what I'm going to do. So I took -6 with -1. I took -3 with -2, -2 with -3, -1 with -6. Those were the first 4 points I decided to copy. And then I copied those exact same points, but on the positive end. Okay. Now, again, if you didn't copy the exact same points I did, it's not a problem. You have freedom to decide which points you want to copy. By the way, the only reason I wanted to copy 0 is because it's an important reminder, and I love that the calculator reports this as an error. It's an important reminder that 0 doesn't work, okay? You cannot do 6 divided by 0. That is why you end up with a vertical asymptote at x equals 0. And remember, now I'm really jumping out of order here. I told you all that every single function we look at today is going to have a vertical asymptote at x equals 0. Every function we look at today is going to have a horizontal asymptote at y equals 0, which means every function we look at today is never going to touch the x or y axis. They can't, because there's an asymptote in those locations that's kind of acting as a shield against the function. All right. But let me go ahead and get to graph. So I wouldn't mind looking at the graph on the calculator just to know what it is that I'm supposed to be getting here, so I can see what the graph is supposed to look like. And now I'm going to go ahead and graph these points. I've got -6, -1, -3, -2, -2, -3, -1, -6. Those are the first 4 points, which help me establish the first half of the graph. Please stop checking that and put it away, okay? If there's an emergency, step outside. Okay, so that is my first half of the graph. Now, I cannot graph anything at 0 because there's a vertical asymptote at 0, and that's already graphed for me. But I can graph the next 4 points. 1, 6, 2, 3, 3, 2, 6, 1. So this is what this whole function looks like. Question so far? All right, and Urim, if you could. Thank you, sir. Now, for the properties, okay, I've already answered some of the properties. I already mentioned there's a vertical asymptote at x equals 0. There's a horizontal asymptote at y equals 0. By the way, make sure you pay attention to which one has the x and which one has the y. The reason vertical asymptotes are called x equals something is because no matter where a vertical asymptote is, it's going to strike through the x-axis. So vertical asymptotes are always named x equals something, okay? The reason horizontal asymptotes are always named y equals something is because it doesn't matter where the horizontal asymptote is, it's going to strike through the y-axis. So it's y equals some number. So while I kind of gave you free points on tomorrow's CFU by pointing out that all asymptotes are going to be x equals 0, y equals 0, it's up to you to pay attention to which is which. Okay, now getting back to properties, let's talk about domain. Domain is about left, right. Range is about up, down. Okay, so domain is left, right. Range is up, down. But in this particular case, we have a function that goes in all 4 directions forever. It's got a portion that goes down forever. It's got a portion that goes up forever. It's got a portion that goes left forever. It's got a portion that goes right forever. This thing goes in all 4 directions forever. However, please remember that it cannot ever equal x equals 0 or y equals 0. Those are numbers that it cannot touch. Okay? So, when you write out the domain and range, you have your choice. These are the same options that I presented yesterday. I do not care if you prefer blue or green. You're saying the exact same thing. Okay, the blue basically says, okay, the domain is every number you can think of except for 0. That's what the blue says. Same thing for the range. Every number you can think of except y can't be 0. And that's, again, because of the asymptotes that kind of guard against the function. The green says the same exact thing, just in a different way. The green says you can go left forever, but stop at 0. You can go right forever, but stop at 0. The range says you can go down forever, but stop at 0. You can go up forever, but stop at 0. Okay, so I really don't have a preference. You can write the blue or you can write the green. Either way, you'd be getting full credit. Now, I'm going, again, out of order here. The fact that this function forever means you cannot name a minimum or maximum value. I would actually argue those don't exist. You can't think of a number that's the lowest this function ever goes because it just keeps going down. Same thing for maximum. There's no highest number. It's not like it reaches 100 billion and then stops. It just keeps going and going and going. So there is no maximum value. Okay. Now, for decreasing and increasing intervals, remember you always read the function from left to right. So I like to think of it as a roller coaster. If I hop on the roller coaster here and then go to the right, I'm going to be going down. If I hop on the roller coaster here and then go to the right, I'm going to be going down. If I hop on the roller coaster here and go to the right, I'm going to be going down. It doesn't matter where you are on this function. If you go from left to right, you are always going down. This is what we would call a decreasing function because it is always decreasing and only decreasing. It never has a portion that's increasing. So I'm just going to copy what I wrote for the domain and then write DNE for the increasing portion. Questions? All right. So on this particular problem, just as a reminder to students, I asked you all to start the problem. I asked you all to fill out the table ahead of me, and then I kind of walked through the rest. I want to do the next problem in the opposite order. I'm going to fill out the table and the graph, and then ask you all to fill out the properties yourselves. Okay? So this says, consider the following statement. The product of two real numbers is 1. If x and y represent the two numbers, write an equation that represents the statement above. So x and y are two numbers. Their product is 1. That is the interpretation of that statement. X times y is 1. Now, part B is something I alluded to in class yesterday. It says, rewrite your equation from part A so it is solved for y. Can anyone recall, how did we get y by itself? What did we do to both sides? Say again? We would divide. What do we divide by, folks? By x. Exactly. If you want to get the y by itself, you got to get rid of that x. So if you divide both sides by x, the y is left by itself. And on the right side, we have 1 divided by x. That is the equation I'm going to type into my calculator. 1 divided by x. So I go to my calculator, and I type 1 divided by x. Now, I'm going to warn you, when I'm filling in this table, I'm not going to be able to get every one of these values from the table, because the table in your calculator, it doesn't show decimal values. It'll show the -4, the -2, the -1, and the 0, and then the 1, 2, and 4. But it will not show the decimal values. Okay? So if I go to the table and I find -4, I can copy -0.25. If I find -2, I can copy -0.5. If I find -1, I can copy -1. Let me just do those first 3 here. But the other thing I'd like to point out, and I'm only doing this because I know I can't get the next 2 off the table. You're not going to find -0.5, which is between -1 and 0. You're not going to find -0.25, which is between -1 and 0. So let me just point out the other way you could have filled out this table is just use the equation. It's 1 divided by x. 1 divided by x. So if I wanted to get this first number, all I had to do was 1 divided by -4. 1 divided by -4, or 1 divided by -2, or 1 divided by -1. That is how I could have gotten those first 3 values myself. So if you continue that pattern, you do it with the next 2, 1 divided by -0.5, 1 divided by -0.25. Then you end up with -2 and -4. Now, you're going to end up getting those exact same numbers, but in a flipped order. Of course, you can't do 1 divided by 0. That's still going to produce an error. You can't divide by 0. But with the rest of the table, you're going to get these exact same values, except they're going to be positive instead of negative. So when I divide by 0.25, I get +4. When I divide by +0.5, I get +2. And then I'm going to get those same values sort of mirror flipped, but again, they're going to be positive. Now, as I said, I would provide the table and the graph, and then I'm going to give you all time to finish the rest of the page. Okay? So I've got -4 and -0.25, -2 and -0.5, -1 and -1. Then I've got, this one's a little awkward, -0.5, -2, and -0.25 and -4. Okay? That's graphing the first 5 points. Now I'm going to graph the last 5 points because I can't graph 0, nothing. That's the vertical asymptote. But I'm going to skip to 0.25, 4, 0.5, 2, 1, 1. Then I've got 2, 0.5, and 4, 0.25. Yes, sir. Resume. There it goes. All right, you may not have been able to finish all of the properties, but I want to go ahead and reveal everything except for part E. I'm purposely not revealing E just yet. Okay, so again, we have sort of the same answers that we had before. For the domain, it goes left and right forever. It just can't touch 0. For range, it goes up and down forever. It just can't touch 0. This is a function that is always decreasing. So the increasing interval is D and E. For decreasing interval, I just copied what I wrote for the domain. For the left and right end behaviors, on both the left and right sides, it's sort of flattening out towards the x-axis. So it's approaching a value of 0. Okay. And as I said before, the asymptotes are going to be the same for every function we do today, every function you see tomorrow. The vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. And for that reason, these functions never touch the x-axis or the y-axis. Now, the one thing I haven't actually revealed yet, it says what happens to the graph as x approaches 0. So as the graph is getting closer and closer and closer to this location where the x value equals 0, the question is, what is happening on the left? Well, on the left side, if you're trying to get closer and closer and closer to 0, you're going to end up shooting down forever. And on the right side, if you want to get closer and closer to 0, you're going to end up shooting up to positive infinity. Okay, so I wrote out something pretty long. I would invite you not to copy this yet. Okay, I wrote something really long. Again, here's a shorter way you could have done it. What you could do is just underline from the left and write negative infinity. Underline from the right and write positive infinity. If you wrote just that on a future test or quiz, like CU, I'd understand what you're saying. Like, I would actually give that full credit because I can follow what you're trying to tell me. I provided sort of a full sentence method, but if you wanted to just kind of write it out in symbol notation, that's fine as well. Questions? We got one more problem to do here, folks. And as I said, with the first problem, you all got it started. I finished it. Second problem, I started it, gave you time to finish it. Third problem, I want you all to try to do the whole thing yourselves. The one thing I want to remind you of, when you are filling in this table, you will not be able to get all of the numbers from the calculator. So you really have to pay attention to knowing how to use the equation itself. The only difference between this page and the other two pages we did is now we want numbers that multiply to -10. So be careful when you type this into your calculator, you need to type it in as y equals -10 divided by x. So if you want to fill in the table, all you're doing is -10 divided by a number, -10 divided by a number. Nope. All right, let's see. How are we on time? Oh, yeah, we're looking good. All right, I'm going to give you all 6 minutes to get as far as you can on this page. When the timer is about halfway through, I'll post my table and my graph, but then I'm going to wait the other 3 minutes to give you a chance on the properties. Go. All right, so I gave students 6 minutes to work ahead on this particular problem. 3 minutes in, I revealed the table and the graph. Remember again that, let me go ahead and take away these 2 points real quick. The points currently shown on the table are the ones that you could read directly off the calculator, but for the other two, you'd have to actually apply the equation and do -10 divided by those values to fill in those 2 missing numbers. Okay. Now, this function is unbelievably similar to the other 2 that we've already done. However, it is now explicitly an increasing function instead of a decreasing function. And that also caused the left and right end behaviors to flip-flop. Now, again, for the left and right end behaviors, if you don't want to have to write out the full sentence that I've provided here, I have no problem with you just underlining from the left and writing positive infinity, underlining from the right and writing negative infinity. If you write that, I understand what you're trying to say. Okay? Questions of any kind? Alrighty. So with that said, students should now be able to do homework number 90. Thanks for watching. Have a good one.